Friends, it's a great delight to have Professor Ramesh Babu for the 14th lecture of the Cree Collective for Reimagining Engineering Innovation. And we will continue this series, and the topic that has been chosen today with Dr. Ramesh Babu is a very important topic of bringing theory, practice, and industry together to create the right kind of vision by which both our engineers are educated with the theory practice nexus and the kind of imagination that such collaboration between the different pieces of a country, different aspects of our country are brought together in order to see how we can transform the engineering practice and education. And especially on this day of Chandrayaan, I think it is a very apt and appropriate lecture. And Professor Ramesh Babu heads the Industry Academic Center for Advanced Manufacturing in Chennai. And with that brief introduction, I will hand it over to Professor Ramesh Babu for the lecture. Please go ahead and share the screen. And I want to thank Sudhir for helping us organize this. And maybe if you want to say a few words, Sudhir, please go ahead.
Yeah, thank you, Sab. I will again take the pleasure of inviting Professor Ramesh Babu, who has done a significant amount of work in looking at this indigenization and supporting manufacturing sector within the country, and the kind of ecosystem that he has developed over the years. Definitely, there's a lot of learning for all of us. So I hope all the participants will also benefit from this discussion and lecture. Thank you and welcome again, sir.
Yeah, thank you, Professor Ishwar and Professor Sudhir, for introducing me to the audience and the other participants here. It's my privilege to share my experiences with the participants of this series of lectures. I have prepared these presentation based on my experiences purely. I have not brought the academic flavor to it, though I intend to do it. But then I felt it's going to take a little longer time. That is the reason why I did not send the title of the topic and also the abstract of my talk. But then at last I felt that, okay, let me share whatever I have gathered over the period of time and shared with many of them, including Dr. Sudhir when he visited my center. So I have just put one front slide to showcase how I have organized my talk to build the ecosystem.
The slide is not visible yet. Please go ahead and share.
Can you see this now? To see this one?
Yeah.
Yeah. So I've chosen it based on my experience over the last 2.5 to 3 decades on the industry academia partnership. Can you see these slides?
Yes,
yes, sir.
Yeah.
Yes, sir.
So what I felt was, though I have material organized or disorganized, but I felt that I would like to convey this message in the following way. What is the basis or a genesis for building this ecosystem with industry, academia, and government coming together and putting the system in place with a lot of effort over the last 1.5 decades, and how we have developed this one, and the approach that we have used is a collaborative approach. And of course, the developing the technologies used another approach called system approach, system thinking. And the next part is how it has impacted, who all have benefited from this one, is the one that I wanted to show through a set of slides and examples where you can see the machines, you can see the technologies being developed for the MSMEs, many startups, and large scale organizations, so as to give the flavor of it to many who would like to establish such ecosystems at various locations. And finally, I would like to acknowledge all my collaborators and partners who have been assisting me over the last 1.5 to 2 decades in establishing the center itself. So first I wanted to start with the approach that I have been following it throughout my career at IIT Madras was a translational R&D. I had a couple of years experience at ISRO Bangalore as a scientist C in integration system section. I think I'm really proud that the Chandrayaan is just landed. That's what I heard, but I have to watch further how it is going to take up in course of time. The next, I went to a multinational company in Delhi, and I had some experiences. And after working for a couple of years in these organizations, I felt the academic fraternity also should focus on the translational R&D. And that's when I have taken up my PhD at IIT Madras in the area of manufacturing, though I did my master's from IAC in the design and worked in the industry on the productionization or manufacturing, etc. So I think this has happened with almost, from 90s onwards. Many industries from abroad, like from Japan, from USA in 2006, and from France, all of them used to come to IIT, and then in one way or the other, I used to interact with them, and that made me to work on some areas related to the manufacturing, which is a precision processes like a grinding, polishing, etc. So when the industries have asked me how you are collaborating with the industries outside the country but not within the country, then I gave a model wherein they wanted to invest and then get the benefit from the intellectuals, either students or faculty or anyone. And then the government, the Principal Scientific Advisors Office has launched a scheme to promote the machine tool R&D in India. And that's when that I took up this process, the project on cylindrical grinding machine development in a partnership mode. And we wanted to make this machine on par with the machines being imported by many industries. And here I have used the collaborative effort. And the first thing is we felt that we need to understand the strengths and weaknesses of our Indian machine tool manufacturers. And then we use the system approach. I think here many from outside, from Saint-Gobain and other places used to advise me on how you should develop this framework. And that's where we have used the system approach. Then we also build the system with the help of industry and validated it with the real time, the activities which happen in the industry. And there are several collaborators who have supported me in providing the tooling, fixtures and components. And after validating it for almost a year and a half, then we transferred this technology. I think this is the basis for me to get into the Center of Excellence on Machine Tools and Production Technology. I think I'll spend some time here, but later on I can quickly run through some of them to give how we used to get these projects from industry as well as the government support. So when this project was sanctioned by the Principal Scientific Advisors Office, it was a pre-competitive R&D. They were not expecting much, but they wanted to focus on the enhancing the capabilities of the Indian machine tool sector. And that's when we approached the industry like Micromatic grinding. Then we went to the association like Indian Machine Tool Manufacturers Association. And through the manufacturer of the machine tools, we approached the end users of the machine tools like Delphi TVS. And then testing facilities available at CMTA in Bangalore, AMTTF. And then a gentleman from Saint-Gobain, Northborough, who was supplying grinding wheels and dressing tools, etc. He graduated from MIT, and then he was the director of surface preparation technologies at Saint-Gobain, Northborough. So he also helped us in showcasing the system approach and then building the entire framework. I think the challenge for many machine tool industries in India is the high productivity machines and high precision machines. That's when we felt that you need to make a survey of the machines being developed by Indian machine tool industries and then identify the specifications for which we have to put our money and effort and collaboration activities. And we identified the strengths and weaknesses of the machine which was identified, and then we finally brought out the technical pathways in the form of a framework for developing the next generation machine. I think the similar approach is being followed for almost all the technologies developed at AMTDC also today. And that's where I'm just spending a couple of minutes on how this framework was developed. So first we went to the end user like a Delphi TVS and asked them, and many machine tool manufacturers using the high precision grinders like textiles and hydraulic component manufacturers. And they all said that the tolerances and the specifications of machines that we use are very high precision machines. And there was a roadmap brought out by the Principal Scientific Advisor's Office in order to develop the next generation machines in India, for which the government wanted to support in the form of both the collaboration efforts and funding, etc. So when we surveyed the components, we found that the Delphi TVS is using the high precision grinders which are imported for making all the types of components which are shown here in this diagram. And we also identified their the features in terms of the concentricity, roundness, parallelism, and finish, etc. And we felt that a machine which we wanted to develop should have the following specifications, and we should bring out that machine so that we can compete with the outside machines being imported. And this is all we want to do it without any gauging, without any sensors and adaptive control. And that is what we have identified. Then we formed the teams from both the sides, the teams ranging from the top executives, top level management to the mid level management to the lower level. All of them have understood why we were developing it. And here again, myself and a couple of engineers recruited for the project and the young students all have worked together. I think about 20 people have worked from our side and about 20 from the other side. And there are several reviewers who used to constantly review this project at a frequency of about 3 months. And then we brought out this framework following the system thinking and system approach, wherein the overall system, the performance can be enhanced only when we look at all of them. So that is where we looked at the machine process and the interaction of the tool with the workpiece. And we formulated several models through the data collected from the machine and also benchmarking it with the imported machine and identifying the weaknesses and stating that these weaknesses have to be removed if you want to make the machine into a better machine. And that's where you can see the entire engineering concepts, right from the geometric measurements, kinematic measurements, volumetric accuracy, then looking at the static and dynamic aspects of the machine in terms of its rigidity and performance, statically and dynamically. And of course, the thermal behavior of the machine is also important if you want to realize the precision uh, uh, precision grinding with these machines. So what happened after a couple of years, it almost took 2-3 years for us to bring out this framework and then file a patent. And at the same time, the industry also has understood where they have to put in their efforts in order to make changes and modifications in various units. So what you see here is the framework which can be used for both characterization as well as the development of the machine by making certain changes. So I think in this particular slide, we have brought out these models into 3 categories like error model, stress model, and thermal model, which is valid for any machine tool of a high precision. And we also identified the errors that arise due to certain aspects. And most of these errors are due to the thermal errors. And we did some experimentation and also proved that if you correct these errors, the machine is likely to become the precision machine. So what we have taken was a machine with some specifications, that is SH63 having much lower precision levels, and by changing the design, assigning the tolerances, changing some of the drive systems, and carrying out some corrections on the drive systems and spindle cooling, etc. So we have been able to bring out this machine with the support of the industry, and that we named it as a next generation precision grinder. And this was inaugurated by Dr. Chidambaram because the office of PSA was supporting this one under the pre-competitive R&D, and it was installed at IIT Madras in June. But then the story did not end with this. Now it has begun. Like they said, that who will buy this machine? How do you sell this machine? Unless you prove it to the customers, and they are not going to believe that this machine is going to give the precision levels that you are projecting it. So then we approached different companies like Bosch, Delphi TVS, Danfoss, you can, and ask them, you please provide us the tooling and also the workpieces so that we will machine them, and we don't machine one or two, we'll machine in hundreds and thousands. And finally we brought out this entire capability chart, and that's when they believed it, and then we transferred the technology. So what I'm showcasing is an example of how the capabilities of a machine tool industry producing the machines at a lower precision has been taken to the next level. I think this company is still with us, supporting many activities and taking up many other projects with the funding from both the government and with their contributions. I think during this time, the PSA's office and Ministry of Heavy Industries and many other ministries also have formulated a policy, and that policy is approved as a capital goods scheme. And this is basically to enhance the uh, competitiveness of the capital goods sector. And in phase one, they said we will support on different activities ranging from technology development, skill development, Samarth Udyog, and facilities, etc. But IIT Madras, we have consciously decided that we will not get into the other activities such as the facility centers and Samarth Udyog and testing and certification centers. And we have stayed on the technology development. Then we also wanted to build an innovation platform to connect the people. It's mostly a digital platform. And then we also offer a lot of internships for the students from different colleges, not only from IITs and NITs. And then we also take the technologies which are developed here to the next level through, again, partnership mode, which we call it as an industry accelerator. So what I'm going to show you in the next 15 minutes is to give you a snapshot of how we have gone about in taking up the projects, from many industries, north, south, anywhere, you can see. And they are our founding partners who have agreed to put in 20% money to get 80% from the government for doing this translational R&D. And that's where you can see the industries are a small, medium, and large scale industries. And mostly they're all the machine tool designers, developers, and uh, basically they are the ones who are supplying the machines to many industries in India. So we decided to set it up as a not-for-profit society, and our director and others said that if you place this one in the research park, it will give a much visibility, and if you have the ability to collaborate with many other industries, it can help the entire center and ecosystem to accelerate much faster. So this is this was inaugurated in 2019 because we did the work parallelly to develop these prototypes and technologies, and also build the ambience for housing these machines, and also keeping our other facilities. And most of them are indigenously built, and none of them are imported here at this center, and they are being used by many others for their uh, startup activities and any product manufacturing, etc. So when we approached this board of IIT Madras, they said that how do you sustain this one? So that is where I just wanted to show at the end what impact this AMTDC is making with the startups, incubators, and many others who are in and around and in different parts of this country. So our vision is basically to look at the translational aspects of R&D, going beyond the translational readiness level 6 and above. So with that vision, we said that first is we will develop these technologies. Second, we will use these projects and this opportunity to train the young engineers from IIT and also from different parts. And that's where we have several memorandum of understanding to bring them and then ask them to work on specific issues related to this technology development. And many of them, if they are enthusiastic and interested, we also encourage them to incubate their ideas with a small money. And then they also go to the next level of a startup. And then some of them are growing in other areas of manufacturing. So overall, this center doesn't work on one or two technologies. It's basically manufacturing covers many areas. And first we started with only the machine tools and various technologies that are needed to make the machines better, either high precision or a high speed machines or highly reliable machines. The second one is we also started working on the robotics, where the robotics and SaaS is becoming one of the key areas in the world. So we felt that many small scale industries need to build these capabilities so that the small robots to the large robots and their capabilities can be enhanced. And we have worked on that one to build several robots and also create automation solutions for MSMEs. And the last but not the least is the digital and smart manufacturing, wherein how the MSMEs can move from one level of automation to the next level of automation, where the digital transformation, digital manufacturing is one of the key areas where they should clearly understand. Then only they can move from the automation level 3 to automation level 4, where the smart manufacturing can really create a change in the entire system. So as I said earlier, I have explained about how we used to approach the problem. We go to industry based on their interests and based on their support, both the technological support and financial support are needed, and they commit, and then we identify the technologies which can be proposed as future technologies or important technologies for each industry. And that's where you can see all these technologies in terms of the prototypes and then finally the machines, and these are being sold by each of these companies not only in India, even outside the country also. And some of them used to have some tie-ups with the other countries, and but when they get this TOT, transfer of technology, there are some gaps which they could not really solve it, and that's where our center and our team will go and help them. And these are the projects ranging from a simple cut-off machines to prepare the metallurgical specimens, where the efficiency of these machines is important, the quality of cut is important. That's how we have gone into the orbital cut-off machines, direct drive machines, and automating the entire line for grinding, polishing, etc. The other one which I have shown you is the high precision cylindrical grinder. We are using it to collect the data and then diagnose the entire machine tool, and then create a automated system for arriving at the cycles and automated dressing and then downtime monitoring, etc. So on the same machine itself. Then other technologies where our efforts were needed by the companies like Jyoti, which is one of the largest machine tool manufacturers in India, and they were importing these technologies, and then we helped them on about 8 to 9 technologies on this machine, which is basically a 5-axis multitasking machine. Then for a small enterprise like Machine Tool Aids Bureau, which is located in Chennai, in Perungudi, and they wanted this sort of a micro machining center for jewelry manufacturing, then mold and dye and dental implants, all these things can be manufactured if these dyes and molds are made on these machines. I think here from the bottom up approach, right from the bed design to the selection of the components and identifying the controllers which can be a what do you call standards like a Fanuc or Siemens. So we made this open architecture controllers. So I think this is where we have showcased the academic expertise of faculty members. I have brought about 7 to 8 faculty to work on different areas and different topics and offer the solutions with a team of people. So in similar way, there are certain technologies which are completely denied, and we have to take them as a package and use them. I think these are some sort of innovative ways of solving the problem. And we looked at the patents, we considered the expired patents, and we studied all of them and came up with several designs. And we have created the test tricks and then implemented them and tested them with the third party. And these are some of the units which goes into the hydrostatic systems, and these can be used in most of the high precision machines for grinding or even positioning, etc. I think these are again patented, and not only Indian patents, even outside patents we have filed it, and some of them were already approved. And I think using this capability set, we have also expanded our domain with the expertise in different areas like manufacturing processes, like water jet technology, suspension jet technology, and we made it to the different defense industries, and we supplied it to them. So those are the ones which we focus mostly on the core technologies or mother technologies, and some of them are for the MSME and some are for the high-end industries where the technology denial existed. And then we use those precision machines, and we wanted to use them more effectively by developing these frameworks and developing the tools like diagnostic system. We developed it first, and then we created the framework to automatically suggest the grinding cycles, dressing periodicity, and monitor the usage of this machine, etc., by incorporating a minimum number of sensors which will be effective for uh, automating the process intelligence. I think this is again being used by the industry. In many industries, they have their own grinders, and they are supplying it, and we are trying to get into the next level of edge computing and cloud computing with all of them. And this is another interesting project where the machines being manufactured by our Indian industries are all at a low precision level. So when they supply it to different users, and due to the temperature and ambient and other conditions, there is a drift in the tool from the programmed position, and that will result into an error, and that goes up to 60 microns at some locations when these machines were installed. I think we have developed the entire framework right from the industrial IoT, and then we also build the controller which can provide this compensation data. And this is where we are again expanding beyond 2 axis to 3 axis, 3 axis to 5 axis with many industries now. So the automation and robotics cover a simple drives we don't manufacture. Even though we manufacture, they're not on par with the standard controllers and drives. So we have taken the help of a few faculty from the electrical, and then we build them and we give it to many industries who can test them on a simple machines, which can be used as a test bed for many research and other studies. And eventually, after establishing the reliability of those drives, we hope to supply it to the other manufacturers of the machine tools also. I think these two examples, which I mentioned as the multi-station grinder and polisher, where the industries are simply supplying the standalone stations, the operators have to move the workpieces and operate these machines manually and handle the workpieces again manually. So we just made the entire automation line with multiple stations with the capabilities of a grinding, polishing, cleaning, etc. So this is a small industry which I mentioned that they wanted to focus on small payload robots, And we imported some of the components, some of the controllers, but then mechanical designs and the assembly integration testing was done, and about 30 to 40% is content, indigenously built, and about 60 to 70 is imported. And now we are accelerating it by reversing it. We have identified the industries who can manufacture these drives and the motors and controllers, so that the import content will become only 30 to 35%. So I think with all these capabilities, many of them have approached us during COVID, just before the COVID, because we have to sustain our activities. And for sustaining, unless we get the funding from the industry and government, we can't sustain. So we felt these capabilities can be offered to many of them as a turnkey projects. We took a couple of them, and that are the ones which I'm going to show it to you in the next couple of slides. And the entire system design, they will give us the specifications, and then we build each unit, and we take the existing units from the factory or from the unit and put them together and then build it. And that's where you can see the actual models and their actual configuration. And we started building these robots for handling these materials and for assembly, etc. I think this is where you can see many of them in this particular slide. So I think you can even visit our website and get many of them. Some of them are showcased as some videos also. So I think with so many things happening, the government felt that you need to have some sort of a platform on which you can connect the people, and this platform should be little more flexible and open, like any other platforms we are witnessing every day, like a Google or a LinkedIn or Facebook, etc. So we took the help of a few faculty from our computer science department, metallurgy, where they have the expertise of using the knowledge graphs to build such platforms. And even the TCS was also kind enough to give a knowledge support with their engineers and heads. And we have made this platform with several features. And the main purpose of this platform is to connect the people, to integrate the knowledge, and to help the students to the professors, engineers to the managers, and any of them who would like to do it as a platform on manufacturing, related issues. So this platform, we call it as a mykite.in, and those of you who wanted to see this one, they can just click onto this one and get more information about the various features of it. And we have launched it very recently after completing the entire platform with the GraphDB approaches. And then we wanted to use this platform to create more talent, and for which the government and the industries were supporting us in terms of offering some internship, stipend for the students. And we started in 2021 August, and we did it online. And we also trained about 350 students on this platform. And that platform is built by the AMTDC with some support from outside. The similar platforms were also envisaged by the ICAT, which is again related to the automotive technology. And machine tool platform is CMTI, called the Drishti. And then RI is again automotive. So I think this is the way that we would like to bring visibility to the talent and the requirements for many young engineers. And some of these are being funded by the government still under the various schemes. And we also make this platform as a problem solving platform. That means there are solution seekers and there are solution providers. We would like to bring them as the mentors. The solution providers are the mentors, and solution seekers can support us in some way through funding or a constant mentoring or a monitoring. And most of these are related to the problems which are being faced by many industries and many other fields like agriculture or textiles, etc. So I think some of these projects are also taken to the next level as incubation level and then startup level. And by seeking the funding from independent the entrepreneurs or the supporters from major industries, and we have made some of them and showcased them in the center, as well as getting the support from them. So now we are accelerating it to encourage more and more young people to come and then interact with our engineers and also collaborate with many others who are located in different parts of this country. And we have signed up the MOUs not only with these industries for whom we are developing the technologies, and many of them from outside the country, from different countries like Canada, USA, and even Philippines and Singapore. They said that we would like to support them through internships and uh, through the creation of a set of problems, etc., in different areas. I think these range from the smart manufacturing, digital manufacturing, etc. And of course, we also have several MOUs with many colleges and many institutes in India. So, and some of them are shown here. And one side we have partners for technology developments. So they support us in some way to take these engineers and ask them to work on specific issues that are bothering them in improving their machines and their capabilities. On the other side, some of the mentors and supporters, to engage their own engineers and their own students to make uh, some talent among them. So then we used to invite some of the experts from anywhere in the country with our own local uh, reach and also outside reach, and they come and address these interns also online through this platform, and they spend about 45 minutes to 1 hour, like as I'm doing it right now. So then we offer some specialized courses instead of offering routine courses, so that the industry as well as the academia can benefit. And these experts are drawn from different institutions and various parts of the globe, and then we help them. And these are all mostly on the advanced topics like mechatronic system, which are these are the ones which are mostly used in almost all the machinery. So we would like to bring in this sort of a approach for designing the machine tools and robots and other smart systems. And then some of the industries who have their machines which are imported maybe 10 to 15 years ago, they wanted to take it to the next level through some sort of a retrofitting or uh, rewiring and reconfiguring, etc. So we are offering some courses to them also. So I think as a whole, with all these efforts, we have created an ecosystem where the three-layered structure or a three-tier structure is used within this AMTDC. And then outside the AMTDC, we have so many people through our own partners and their engineers, experts, R&D centers which are located at their industries, and governing board, an advisory committee, and then several MOUs with all of them. So as you can see that this sort of an ecosystem consisting of about 200 to 250 people are the ones who are supporting this AMTDC, and then we continue our activities with their support. And this has resulted into a center which is a virtual center. So since we have been working on several areas like digital manufacturing and smart manufacturing, and many of them, and they have seen the entire environment and ecosystem, they felt let us have collaborations with some of the agencies like MESA International is one thing, and then APAC is on the other side. One is in Americas and the other one is the Asia Pacific region. And the Cantier CEO is the lead person in that APAC side. MESA International is somebody from Canada. So this is where we have brought out the center with the aim of assessing the capabilities of many MSMEs, educating them and training them on some specific tasks so that they can transform their center or MSME into the next level automation. And this is where the MES and smart manufacturing solutions will be provided either by us or by many other groups, which are part of this entire ecosystem as a member of the special interest group. So this is how we have formulated and then inaugurated by the chairman of the Tata Sons with our chairman, uh, our Pawan Goenka, Dr. Pawan Goenka, and then Director Professor Kamakoti. So in 2022. So here we would like to make the center though virtual, but as a center for making the solutions easier and building the solutions which are cost effective. And the center where we have all these facilities in the research park will also serve as an experience center to give them an idea about how you can translate your machine into a smart machine or into a better machine, etc. I think if they require some support, we are willing to extend our arm and then support them. And this is the way we thought of in helping many MSMEs in the country. And we have been having dialogue with them, and their teams will come and visit us. And we are providing some solutions to make this experience center as a valuable tool for them and also for the nation as a whole. I think we give these projects to the young students either at the bachelor's level or a postgraduate level, and ask them to understand how the data can be retrieved from the controller, how you can access them, what type of protocols, what type of algorithms, and the data analytics, and all these things can be easily explained to them. And if they are enthused and motivated, then we'll also ask them to work on these projects for a period of 6 months to 1 year. I think this is how we have extended our arm to many other areas like smart manufacturing and Center of Excellence on the smart manufacturing. I think this is the one. The third one, which I mentioned, is how we are making an impact on the startups and the faculty members who are inventing new processes, new methods. And many of them who develop a process on the tabletop, they don't know how to take it to a level of reliable system with which they can conduct a series of experiments and collect the data and publish the data on one side. And if these systems become reliable enough to make it as a startup, etc., so we will also encourage them. So this is where you can see the metallurgical professors and civil engineering professors working on 3D printing have approached us, and we did this, and we gave it to their students to carry out their research work. And many of them from the SMEs, MSMEs, and OEMs, they approach us, and some of them go to Fraunhofer and other agencies outside the country. And when they approach them due to the costs and then various other constraints, they also approach the AMTDC and IITM, and that's where will become partners in this entire collaborative effort by signing the NDAs with each of them and then offering the solutions to the extent that we can offer. Then, of course, small and medium industries come up with some problems. I think these are all appear to be very routine, but this is the type of support that most of the industries require. And most of them don't open up initially. We have to go and then tell them that this is the capability that we have it. And in some cases, we even bring out the designs which will help them to build their systems with their own supply chain and ecosystem, etc. I think this is we just build them and then or design them or provide the solution to them from end to end, etc. So I think a range of them can be seen through a set of examples here, like Arica leaf based tableware. They were producing it with the die and molds which were designed by amateurs, like from the job shops. Then when we analyzed and found that there are so many deficiencies which we could correct it and provide a new set of tools and uh, reconfigurable or a replaceable tooling, etc. Then the same thing with the textile industry in Surat, and we gave them a solution, and they said they will get it implemented. And many startups who are in our entire ecosystem in IITM Research Park, which is located next to the IIT Madras, and in the initial phases that they approach us and we give them a solution, or we manufacture them and give it to them, and they will in turn expand their activities. And that is how the entire AMTDC ecosystem is supporting many startups and incubators, etc. And of course, the story continues. The phase one was over, and then phase two was launched by the government in 2020-21, and the money was almost 4 times the money that was initially allocated for the phase one projects. And we have been lucky enough to get these technology development projects. We have expanded our clientele from the previous 6 partners to 4 more partners. And whatever technologies we have developed it in the phase 1, we would like to put them on the machine and make these machines into high precision machines. And these are all the user approaches the industry solves some of them they're not able to solve, then they'll come to us and we project it as a project. And these are all again accelerating the robos from 10 kgs to 200 kgs. And we would like to get all these aggregates manufactured by a few companies in Bangalore and the other places, so that the end users also will be part of this ecosystem. After these systems are made and integrated, then we launch them to test their reliability with the support of end users. And they're all the auto tier 1 suppliers or the OEMs, etc. So this is where the story goes on, but I have many more things to share. But since you have given us about 45 minutes, I felt that I need to showcase some of them. I think our reach is to almost all the associations, and many of them have supported in order to build this entire ecosystem. And without their support, we would not have really gone further. And we are also promoting through the media partners, Pro Manufacturing, which is again the Birla Group company. And this is what I wanted to share today. And there are several advisors from outside the country and inside the country, from IITs and industries, etc. So I just would like to take our team and the technical as well as the engineering team is working to solve all these problems. And many engineers from the industry also will approach, and they can spend their time at the center for many days, unlike the IIT labs where they'll have very little space and time to spend. So this is in a nutshell our ecosystem, and we are located in the research park. And you are most welcome to visit if you are around or whenever you are around. And I would like to invite you, and if you give me advanced information so that we can also explain the various activities and give a demo of the technologies that we have developed. So I would like to take a few questions if anyone has anything to ask. Okay. Thank you.
Sir, thanks for the very detailed presentation. So we'll invite from any questions you have, please unmute and then ask your question.
Yeah, I got one question to ask, sir.
Yes, yeah.
Please go ahead.
Yeah, regarding the financial aspect, whether your this ecosystem is sustainable, or which way it is now after starting, now you are sustainable, or which way your
Yeah,
economic
we are sustaining. We are currently executing about 6 projects with about a good amount of funding from the government and industry. So unless they put in 20%, the government will not give even 1 rupee. So we are sustaining it and we are accelerating it.
Okay, thank you, sir.
Thank you. Yeah.
Any other questions?
If there is nobody else, I would like to ask a question.
There's one question I have, sir.
Yeah, go ahead. Go ahead.
Yeah. So so it was good. The presentation was nice, sir. I wanted to understand MSME sector. What are the key challenges they are facing? Especially, you mentioned about the retrofitting part. So, what are the things which their MSMEs are asking to solve?
See, I'll put them in different baskets. One is the MSME is constantly struggling for the finances, energy, manpower,
Right.
sustainability of their activities through the trained manpower. See,
Right.
most of them stay for only 6 months to 1 year and then look for better opportunities in other companies. And once they get trained, they just shift from one company to the other company. There is no commitment from the employee side except for a couple of months. They have to stay before they leave. The
Right.
second one is the funding, the bank loans, funding, and interest rates are the ones which are bothering them too much. The third one is they don't have the appetite to change over from the existing levels of automation to the next level, and many of them even at the industry 2.0. So they don't even understand what is digital transformation. We have to educate them on
Awareness of it has to be there.
yes. So this is where a range of problems are bothering. When we approach them and we invite them, they're excited, but they don't have the appetite to absorb these technologies and this knowledge. And this is true almost all over the world. But I came to know from many experts who visit our center and then
Right.
share their experiences, and more or less they are in the same level. They are at the
Right.
same categories. Okay.
Okay. Yeah. Thank you. Just a follow-up question. Can I ask, sir?
Yes. Yes.
Yeah. In your opinion, what would be, let's say, as a center you have, what would be a way to encourage MSME to look at the technologies which are there, Industry 4.0 technologies are there. How do they get excited and adopt these technologies? Like,
I think we have created this smart manufacturing and
correct.
digital transformation center as a virtual center,
Right.
keeping all those technologies on one side and developing add-ons, for those technologies layer by layer, and giving a demo of these digital transformation and smart manufacturing experiences to them. Then when they go back, they can decide at the managerial level, at the any level, and then say that we wanted to do this one. We'll help them, and they can send their engineers to our center, or we will send our engineers to identify the problems, and they can collaborate with us with little money and little effort. They
Right.
don't have to think of a huge funding and huge effort, from their side.
Correct. So make it more problem bit smaller so that it is accessible and it is also
Yes.
visible.
So if we offer a solution like an academician offering a big solution, they are not able to digest that one. They don't want that.
Right.
They want to solve their problem step by step in a short period of period.
Right.
In
So
a
there
short
has to
time.
be a systematic way
Yes,
to.
yes. So they have to grow, and for which they need both internal capabilities and capacity to absorb, and then only they can take it up.
Right. Thanks a lot, sir. That answers
Thank
my
you.
question.
Yeah.
Sir,
Yeah, go ahead.
one more question I want to ask. I am Pulan here.
Yes. Yeah.
Yeah, in our SMEs, what is the level of smart manufacturing penetration as far as India is concerned? How much percentage of the industry in SME can adapt to this smart manufacturing?
See,
Or
yeah. Let me tell you, IMA, a Management Association, has done a survey long back in 2018-19. About 45 lakh MSMEs are 45 lakhs or more than that. So they don't have any clear-cut idea about where they want to go. But there are MSMEs who are working with the auto giants and auto component manufacturers, tier 1 suppliers, and they are equipping themselves to the level of automation and smartness needed, because they have to supply it to these giants like Wheels India, Brakes India, Sundaram Clayton, or TVS, etc. So we can't generalize it and then say that okay, this percentage, and no statistics is available now or available now to tell that this percentage. Of course, we can just speculate it and then say some percentage, but reality is that every association is trying to support them, but then as I said, their problems are completely different from what we think of in academic institutions or R&D establishments.
sir, is it due to economical financial factors, or some other factors?
Many. Some of them have become senior enough, old enough to hand it over to the next level, but they don't have enough, level and competency to take over from them. That is one side. Second one is the financial issues. They have to take the loans and then invest on that one. Third one is the guarantee for the effort that they are putting in terms of the finances and the time and effort. So there are several issues which are bothering them.
Yes,
Okay.
thank you, sir.
Yeah.
Your presentation is very nice, sir. Very informative.
Thank you. You are from which place?
I am from Cochin, Kerala.
Oh, thank you. Yeah.
I also worked in the industry, this manufacturing industry, almost 23 years. Now I am with academics.
Where, in which college?
I am with Rajagiri Engineering College, Cochin.
Oh, excellent. So, thank
Right.
you. Yeah.
Good evening, sir.
Good evening. Yeah.
Hello.
Hello.
Sir, good evening, sir.
Yeah.
Hello, sir.
Yes. Yeah.
Good.
The presentation is very nice, sir.
Thank you. Yeah.
And it's a kind of digital transformation, like a digital tin.
Yes.
Sir, I have a question. Maybe I may ask that question in this platform or not.
Please
But
ask.
anyhow, I am putting this question.
Yes. Yeah.
Sir, presently, in educational system, when we are looking into educational system, anyhow, we are having new technologies like AI, ML, and different kinds of technologies. But they are downfalling the other engineering departments like mechanical, civil, and electrical engineering. But will this digital transformation help to bring up the other kind of branches?
I'll tell you, if you know what is smart manufacturing, it is an integration of operational technologies with information technology. So,
Yes,
if
sir.
anyone is thinking of only information technology will solve all the problems, it is only a myth, but not reality. So, hence, we need to educate the policymakers and management and the young, students, budding students, that it needs both sides. Without the core technologies, without the operational technologies in any branch like civil, mechanical, electrical, chemical, metallurgical, textiles, everywhere, those technologies are the building blocks. Then
Yes,
only
sir.
you can think of information technologies, computers, IT, Wi-Fi, and machine learning, etc. Please educate the management, administrators, policymakers, and how this OT plus IT only can make a change in the smartness of the systems. And if you don't do that, we are just going to constantly be afraid of this IT or any other new technology that is going to come up in the next 1 or 2 decades. So this is a must. So this is the process of education which is going to enlighten the people, that should be taken up by a few at the top. We do it at IIT, but it is not enough, and every institute has to think about it and then encourage the young students to. I think tomorrow will be short of all the civil engineers, mechanical engineers, electrical engineers. Then you will only see IT engineers. They don't know even how to do the plumbing, carpentry, or fix up the problem, etc. And that's going to be a big problem for the world as a whole.
Even now also we are struggling
Just,
with a lot of
yes. Sorry to
related to.
interrupt.
Yes, yeah.
We'll take one last question. Professor Subramanian had a question.
Yes, yeah.
Thank you for a lovely presentation. I think the last point you made is of very great importance, and we can certainly extend a little bit more time for questioning, but nevertheless, I think
Yes.
it is the combination. If you don't have basic engineering, IT is an icing on top of basic engineering. People, you cannot put icing when you don't have a cake. So you
Yes,
have
yes,
to make
yes.
the cake first, right? And I think
Yeah.
this distortion in the educational process, as you correctly point out, has to be redressed in a
Yes.
very systematic way. And also the fear of working with one's hands has to be taken away so that people know that unless you use your hands, you cannot understand the material, you cannot understand uh, uh, the composition of materials, the use of materials, and
Yeah.
a personal relationship between material and you is very
Yeah.
important for engineering. And I
Yes.
think I'm
Yeah.
really thankful for your talk. And my question is, how do we replicate this around the country? Because
Is
one
the
center cannot solve 1.4 billion people's problem.
through the collaboration. I think you all know the collaboration networks, which were being talked about all over the world. They only talk about the supply chain management networks.
Mm-hmm.
But I think we have to come to the ground level of manufacturing networks, and production networks.
Uh-huh.
And I think I am doing my best by stretching my arm to the small, to the towns. We're just going and then trying to replicate this model. So that's why so many collaborators and so many people who are supporting me, they said they will put their money, they will make their investment. They wanted to bring the rural manufacturing. It can be a waste to wealth, or it can be a cleaning robots. So I think we are doing at various locations like Madurai, Chirala in Andhra Pradesh, and Bangalore. So only way is large number of people. It's like a movement wherein we got the independence through the non-violence now. So unless we just get that movement through the collaborators and well-wishers and supporters and advisors, I don't think that we can get it done by the government. Government will open up the advanced centers. Today I have seen Tamil Nadu Advanced Manufacturing Center. But then on paper it looks fine, but when you go there, all the imported softwares and equipment will be there. But if you come to our center, there is nothing is imported except the controllers, computers, and even computers are being made here. Unless we make this as a movement for making the next generation of youngsters, I don't think that we can ever reach any level in the near future. And this is where I share my thoughts with everyone freely. And unless we have that sort of a collaborative, and we also do a lot of things with collaborators, and unless you bring this spirituality into practice, and I think it's going to happen. So this is my last word, saying that if you are spiritualistic, then you tend to think automatically that what for I'm here and what I need to do it ultimately. And that will come from the entrepreneurs, industrialists, and investors and everyone. So
Sham has a question. Go ahead, Sham.
No, I just want to thank Professor Babu for an excellent, enjoyable talk. And I couldn't, since I'm in doctor's office, I couldn't attend all of it, but I'll follow up later. Thank you.
Thank you very much for your acknowledgement and the wishes that I want need support of all of you to make this globe better. I'm not looking at only India. Unless we have the talented youth who can go into the manufacturing, I think the world is going to suffer.
I want to make a comment along those lines, Professor Babu, because I've been talking to a bunch of people in Bristol, and they have similar problems that IT, everybody is running to IT, and the manufacturing is suffering in many of these places. And one of the things I wanted to ask, because what is impressive to me is that you are able to see this because you worked in industry. You have seen the world on the other side, whereas most of our faculty do not see the other side of the world, and hence are not able to participate in any meaningful way to enhance. So my question to you is, how can we mobilize people like you to actually get involved in creating more of these centers around the country? Because I think we are not using the resources we already have in a meaningful way to enhance both manufacturing and the kind of training you are providing. And maybe it should even be integrated into the bachelor's degree program than just be outside. I would like your thoughts, please.
Professor, there are 2-3 things which I want to share it with you. One is the individual academicians are self-centric for obvious reasons, because you choose this position to be more independent, more authoritative, either through ignorance or innocence or awareness. Unless we create that sort of a spirituality in mind, in practice. In fact, myself and Dr. Subbu Subramaniam from STIMS Institute, during the COVID, we felt that for every human being, there are 3 legs. One is personal, social, and spiritual. Unless you bring the dimensions into the education, we are not going to change the mindset of the faculty, mindset of the young students, and the management who is supporting such programs. In my opinion, in fact, when Texas A&M senior provost visited our center, the same thing which you have mentioned was uttered by him. So in 1 or 2 statements or seminars are not going to change it. I think we have to make them part of the system, for which government is, Niti Aayog is thinking how to replicate it. In fact, Saraswat, many of them, like including Dr. Satish Reddy, we were all there. But it is not going to happen just like magic wand, You have to sit and work. It is 3 decades of work, which I am showing it in 1 hour. So, in my opinion, creating an awareness, making them responsible citizens, changing the policies for promotion, and awards and rewards are the only way forward. We give the awards and rewards for the citations rather than giving the achievements. So I think, this is where I tell the directors and others, but the problem is I can't change it now. I will take some more time. And when is that time? I don't have any clue when that is going to change it. I think we have to be a little more aggressive in promoting it. I do it at places where I have an accessibility, but I can't do it everywhere. And somebody was asked me whether you sustain. Sustenance is not at all a problem for me, but getting the right kind of people to work on the problems is the most challenging for me.
So do you think
one of the suggestions is like, if every institution takes a commitment to build one world-class machine for something in their locality, then they can network with centers like yours and actually learn from that and deliver that. That will mobilize a lot more institutions to move forward. Maybe some direction like that should be given to all the institutions. At least pick up one machine and build it.
Yeah, I think what Sudhir is pointing out is extremely important. What I have seen in other places, some in China, some in Germany, and so on, the local industry, the local institution, and the local government are partnering together to create an ecosystem. And I think that becomes a very important part of the expansion of such capabilities. And this has to be sort of even a national policy to allow and provide funds for these kind of activities. I'm from CMU. The number of local industries partnering through a variety of incentives provided by the state to create these partnerships has been very effective to an extent that even Pennsylvania has called something called the Pennsylvania Innovation Council, whose job is to bring academics, industry, especially SMEs and MSMEs, which constitute the backbone of any country's industrial base. It's not the big boys who run the country, it's the small guys who run the country. And I think it is a focus on that. I also spent time at the National Institute of Standards, which has a manufacturing extension program effectively to support these industries. And I really think what you are doing is absolutely remarkable against all odds in an Indian context. And to replicate that in all different places around all regions would be the challenge that we face, I feel.
I agree with you, Professor. I think I am always open for any thought processes, and I have reached to associations and industries. But only thing is, I think if we have many such thought leaders in India at various institutions, then we can form a special interest groups as a special interest group to debate on these issues and bring out a framework or a policy document. I think that is the way forward. But the workhorses are also equally important. See, the policy framework can be drafted nicely, but then unless these things organically develop, organically grow, the sustainability will become a challenge for many. That is where the one-time grant of 100 crores is not going to help the system. Even if you start with 2 crores or 3 crores, I have come to 100 crores. It's an organic growth with me as one of the thought leader on this. But many others who are following me and who are working with me do not have that confidence and courage. See, these two are to be built through, again, a consortia approach with the collaboration networks. See, then I think different layers we can formulate it. The industry is also very slippery. Industry will never be with you unless they get something from you.
Mhm.
Okay. So this is where we have to build the confidence in some groups of industries in and around or wherever they are. And then I think the sustainability will become a natural process. Okay. This is, I think this is where I keep debating with many of them. And they want to emulate it and they want to replicate it. But they also find it difficult to put in their effort and then launch it. Okay.
So somebody wants to say something. I
Yeah.
think
Sir, one question from my side.
Yeah.
Probably this may be the last question. I am Dr. Bacha from Pune.
Yes.
The government, state governments, and the universities across the country, they are implementing the new national education policy. So
Yes.
we can take, academicians can take this as a platform, and
Yes.
can we make our academical syllabus in such a way that it will boost or it will be a collaborative work with MSME and academics. So that is a very good opportunity for all of us to implement something in national education policy the way you want to put forward here for the development of this manufacturing sector. So
Sure, certainly. I think we have to work out different models. No, I agree with you. In fact, College of Engineering Pune, their chairman, he is the brother of Baba Kalyani. So he visited, and then they're also thinking of developing a research park very close to the College of Engineering Pune. I think it has become an autonomous college. I think, see, by observing it and then seeing the progress, I think many also will get inspired and then they try to replicate it. It is a good sign. I think that's how we have to slowly build these networks also. Okay.
yes, sir. College of Engineering has implemented that. They have established a Bhau Institute,
Yeah.
through which they can helping for startups, and they are developing some incubation centers. So
Yes.
thank you, sir, for your valuable inputs on this.
Thank you. Thank you. Yeah.
I just want to make a remark, Professor Babu, that
Yes.
this need not be the only lecture you give. You are welcome to come to our forum anytime. And
Sure,
we
sure.
not only we are willing to use the same time for
Yes.
having discussions of this nature with many of the people who are present today. And we will, Sudhir and I will contact you for a potential future location, future time, where we could have this discussion as a sort of a debate and discussion forum rather than purely a lecture. I hope you would agree to participate.
I am always for the nation, for the for the humanity. That's all I can say. I have nothing against that. Okay.
We have created this forum precisely for that, and also we have called it collective reimagining because I think it is a collective process. It's not one individual has money, a single individual together the coming together with a common vision is what is needed. And with that, I think I'll ask Sudhir to close the session.
Thank you, Professor. I think nice to see you online, but I want to see you in person when you are here.
I'm in Chennai now, and so what I will do is I'll send you a message. I'm here till the 30th of September, 30th of August. I'll try to come by and see you before I leave.
Sure, sure. Where are you in Chennai?
In Besant Nagar. I'm not very far.
Oh, then you can just drop in from the backside door of IIT. So this is IITM Research Park. Hardly 5 kilometers or 6 kilometers.
I was there a few days ago, so I can come.
Yes, thank you. You are welcome, and others are also welcome to see. At least we can share some thoughts and then have a cup of coffee and then see how we can move on.
Absolutely. I might plan to see you on Monday.
Sure, definitely. Thank you very much. Yeah. Thanks.
Sudhir?
Thank you. Yeah, thank you, Professor Ramesh Babu, for sharing your experience, and also all the participants for joining this session. The next talk will be on 2 weeks from now. We have a talk on medical devices coming up on, I think, 6th September is the next talk. So we will catch you up again during that. So thank you again. Thank you all for joining.